Welcome, welcome. These are going to be the second part of the 4-1 notes. If you are in either my first or fifth hour, you've already learned how to convert between degrees and radians. In general, I'm just going to go through the notes, not in great detail, just so we can keep these videos short. The first thing that we're going to go over is how to convert from degrees to radians. Again, radians is a way to measure an angle in terms of a circle's radius. If you have degrees and you're going to radians, you're going to multiply by pi over 180. An example of this would be if I want to change this 135 degrees to radians, I'm going to multiply by pi over 180. In your calculator, the best way to go about this is to maybe just pretend like the pi is not there and get a working calculator for that matter. So in your calculator, I would do 135 divided by 180, then math fraction. That will simplify the fraction, and then to take care of the pi, just put a pi on the top. So this, as a radian degree, or sorry, as a radian measure, would be 3 pi over 4 radians. You can try the next two. When you get back in class, if you want to double check with me, you can on those answers. Here, if you're going from radians to degrees, you're going to multiply by the reciprocal, which is 180 over pi radians. An example, and it's fine if it's negative to start off with. Here we have pi over 2 radians. I want to change it to degrees by multiplying it by 180 over pi. There you go. And so here we go. And this maybe you could even do in your head. What's going to happen when you change from radians to degrees is that you're going to, most of the time, have a situation where these pi's will cancel out. And then you can take, well, see, 2 goes into 180 90 times. So this would be negative 90 degrees. Right? You can try J and K and also come back and check your answers with me on those. So now we're going to go actually above this, where it says complement and supplement angles. If you remember from geometry, complementary angles are going to add to get to 90 degrees. The radian equivalent is pi over 2. Supplement angles are going to be angles that add up to get to 180 degrees. The radian equivalent of that is pi. So if you want to find the complementary angle to 2 pi over 5, all you do, I'm going to write C for complement, is take pi over 2 and subtract 2 pi over 5. Same deal with calculating. What you would probably want to do is pretend like the pi's aren't there. So for pi over 2, go ahead and put in 1/2. And then subtract from that 2/5 to handle 2 pi over 5. You can make that answer a fraction to get 1/10. And to deal with the pi, it would just be a pi on top, so pi over 10. So the complementary angle in radians is pi over 10. To find the supplement, you are going to do the same sort of process. Let's see if that helps a little bit. But in this case, you're going to do pi minus your angle. So it'll be pi minus 2 pi over 5. When you put pi in your calculator, just make it 1, because it's 1 whole pi, minus 2/5. And then math fraction, put a pi on top, so 3 pi over 5 would be your angle. Just to kind of flash forward, when you do the complementary for this particular angle, it ends up being a negative value. I think it ends up being, let's see, it ends up being negative 3 pi over 10. If your complement angle ends up being negative, then there is no complement, right? Because there's no negative complements in life. So that is complementary and supplementary angles. If you want to find the supplement to this one and come back in to check your answers, that would be awesome. All right, we're going to move to the front bottom of the 4-1 notes. So back to the very first page of the notes and then down to the bottom. We are going to talk about coterminal angles, and we started talking about that the previous day in class. What you're going to do is just add and subtract a rotation in degrees. This is what we filled out yesterday. A full rotation would be 360 degrees. The equivalent to that is 2 pi radians. So off to the side, you might want to write yourself a note. If your angle is given in degrees, you're going to take theta, which is your angle, and add or subtract 360 to get the coterminal. And then for radians, you're going to add and subtract 2 pi. Sorry, make it more readable. So for radians, theta plus and minus 2 pi. So let's find the positive coterminal for A. So I'm going to take 13 pi over 6, and I'm going to add 2 pi to it. In your calculator, just pretend like the pi's aren't there. So it'll be 13 divided by 6 plus 2. Make that a fraction. So the positive direction coterminal angle would be 25 pi over 6. The negative of that is going to be the same thing, except for now you're subtracting 2. And 1 pi over 6. The same goes if the beginning angle is negative. To find the positive, you can add 2 pi. So in your calculator, you would do negative 2/3. Plus 2. So the positive coterminal angle would be 4 pi over 3. And the negative would just be negative 2/3 minus 2, math fraction. And that would be negative 8 pi over 3. Forgot my pi. If you would like to do the middle one, come in and check with me. That would be awesome. All right, I know we're flipping around a lot. The last section is going to be over these two formulas, mostly focusing on this arc length formula. Like I said, we are taking these angles. We're going to be putting them on circles and on the coordinate plane. And for arc length, we're going to specifically think about it in terms of being inside of a circle. So I'm just going to put a little visual with this. If here's my circle, here's my radius, here's the central angle that I'm going to focus on. On the edge, that is going to be your arc length, and they use the variable s, which kind of makes sense because s is a curvy letter, so arc length is curvy. So here's the deal. So the formula is s is equal to r times theta. The deal is that this theta needs to be in radians. So if it's given in degrees, like this particular problem, we are going to have to convert it. So here we go. We have a circle and its radius is 4 inches, so r is equal to 4. The central angle theta is 240 degrees. So what we need to do is convert it to radians by multiplying by pi over 180. And to, I guess, make this faster, that ends up being 4 pi over 3. Last step, so now we have our radius, now we have our angle in radians. To find the arc length, s, just multiply them as r times theta. So it's going to be 4 times 4 pi over 3, which gives you 16 pi over 3 inches. Now, saying 16 pi over 3 inches doesn't really give you a good idea, in terms of measuring it on a yardstick or so forth, how long that would be. So go ahead, let's put 16 pi divided by 3 in our calculator. So our arc length is about 16.8 inches. The next one is angular speed, and it's talking about the old lawn machines, or the lawn mowers that didn't have a blade, or no, sorry, didn't have a motor. And this lawnmower is making 1.2 revolutions per second. So what's happening is it's rotating around and then just a little bit more every second. What it wants us to do is find the angular speed in radians per second. This is all just pig pens, if you remember those from chemistry. So we're making 1.2 revolutions for every 1 second. If you think about it, one whole revolution, that's one full circle. So in degrees, it's 360, but in radians, because we want radians per second, it's going to be 2 pi. So one revolution is equal to 2 pi radians. What happens is that these revolutions cancel out, and then you get 1.2 times 2 pi, which is going to be 2.4 pi radians per second. And that is it. Thanks for tuning in. The homework is at the bottom there. Those are multiples of 5. And actually, now that I'm remembering this, for 57, you can skip part A.